Welcome to the celebrated High Achievers Mentorship Program, CHAMP. In this video, we'll be talking on electrolysis. So, we'll just be treating electrolysis calculation. That's the only thing we'll be doing here. So, yes, it's actually derived from Faraday's law of electrolysis. The first law saying that the mass of an element discharged in electrolysis is directly proportional to the quantity of electricity that's passed through it. So from this equation, I can say M is equals to what? I want to introduce my electrochemical equivalence. This is ZQ. So this is my electrochemical equivalence. Let me just stop on this a bit. The unit for this is always gram or kilogram. Electrochemical equivalence is what? Gram per coulomb. Why your Q is what? Q is what? Q is equals to IT. The unit of I is what? Coulombs. Where Q stands for quantity of electricity. The unit of I is what? Current. In what? In ampere. Why the unit of T is time in seconds. So M is equals to ZQ. So I can slot this in that M is equals to Z. What's Q? IT. So anywhere I see Q, I can put my IT there. M is equals to ZIT. So this one formula then. Let me just give you some formulas that is fun to you through. M is equals to ZIT. M is equals to MQ over NF. V is equals to MVQ over NF. Then mole is equals to Q over NF. I think these are all the formulas you're likely going to need for this topic. Yeah. So with this formula, you should be fine. So yes, let's just M stands for what? Your mass. Capital letter M stands for your what? Your molar mass. Q stands for your what? Your quantity of electricity, which is what? IT. N stands for your what? Your number of Faraday. 1 Faraday is equals to what? 96,500 coulomb. So if you have 2 Faraday, that is your N is 2. That's what? 2 times 96,500 coulomb. If you have 3 F, that's what? 3 times 96,500 and all of that. Mole is mole, N is number of Faraday number. Yes. Let me just give the N for some common elements. The N for some common elements. Yeah. So let's take that now. So please take note of this. Master the formula over and over again. Yes. So let's go. You have N for common elements. For common ions or anything. Z for zinc is what? Is 2. For potassium it's 1. For gold is 3 or sometimes 1. Yes. Then we have some other elements. Iron, it can be 2, it can be 3. Iron is actually not common in electrolysis. Oxygen, it is 4. Yes, it's 4. For chlorine it's 2. For which other one? Hydrogen it's 2. For magnesium it's 2. And on like that. On like that. So that's how it works. That's how it works actually. Yes, you can be wondering how do we get this one? For zinc now it's from this equation. During the electrolysis of zinc, we'll have something like Zn to give you Zn2 plus 2 electrons. It's actually the number of this electron that we are writing. 2 electrons. Aluminium is 3. I hope you know that. The same thing for gold. So you have Au3 plus 3 electrons. So things like that. For oxygen, this is how we got that of oxygen. OH minus to give us oxygen plus water. So if you try to balance it, this will be 4, this will be 2. But it's not balanced yet. So this is actually what? Plus 4 electrons. So you have 4. So it's actually something like that. It's actually yeah. So this is just how it is. This is how it is. Actually this one should be the other way around. It should have been something like this. Zn2 plus 2 electrons. Yes, to give us Zn. But what I'm emphasizing is that it's 2 electrons. So it's the 2 that we have here. So yes, let's just revisit our old formulas again. So I'll just help you to write it in the top right hand corner here so that you can refer to them whenever you need them. We said M is equals to ZIT, right? Then we said mass is equals to molar mass Q over NF, right? Then we said volume is equals to molar volume Q over NF, right? Molar volume is what? 22.4 gm cube. F is what? 96,500 coulomb. Then the last formula mole is equals to Q over NF. So yes, that's just all the formula you need. Let me clean. So yes, we just begin to take questions now. Then at a point, okay, yes, maybe subsequent video will be released where we'll talk on other aspects of electrolysis. So just watch out for that video. We'll be explaining some basic processes in electrolysis, like electroplating, every other thing. Yes, the reason for the preferential discharge of ions. So yes, but this will just be calculations majorly. Yes. So let's go now. So yes, let me just take some questions from here. So let's move. So we have our first question here. Yes, they said, please permit me to get the question. So we are told a solution of CuSO4 is electrolyzed with a current of what? 6 ampere flowing for 5 hours. Calculate the mass of copper deposited. Then they gave you your 1 Faraday to be 96,500 coulomb and your copper to be 63.5. So it's as easy as that. So yes, whatever you ask, calculate the mass. What's the formula for your mass here? Mass is what? MQ over NF. Yes, what you determine the formula to use, you have two mass here, but here you need your Z. You need here. You can see F is needed, and you have F here. You need your molar mass 63.5, and so that shows that you are using this formula, not this. Do you understand now? And also, if you are to use this one, you need your Z, but here you don't have Z. So that first formula is actually not appropriate. So let's go now. Mass is equal to, what's your molar mass? 63.5 times, what's your Q? I told you that Q is equal to what? IT, right? So times I, what's your I? 6 ampere. Times time, what's your time? 5 hours. Will I write 5 hours? So you convert 5 hours to seconds. So times 60 makes it in minutes, then times another 60 makes it in seconds. Anytime you are given a time in hours, so it will be what? 1060, 1060. If you are given a time in minutes, it will be what? 1060. This is for hour, this is for minutes. Over NF, what's the N for copper? I gave you the other time. So this is 2 times 96. F is what? 96,500. They also gave you. So you just press this one in the calculator. So I will press my up, the one at the top now. Then I will press the one at the down. Then I will just divide and see the answer I'm going to get. So yes, 63.5 times 6 times 5 times 60 times 60 here will give me 685,800. Yes, so this is it. Then if I press that of my down part very well to give me 193,000, so I will just try to divide it. Then I see the answer I am going to get. Yes, so yes, let me just try to press it from here to see the answer I'm going to get. 685,800 divided by 193,000. So yes, that is going to give me 35.5 grams. So this is my answer, and this is the answer to that question. I hope you understand. If you don't understand, you can just play back, try to watch it again, and make sure you get it before moving on. Yes, let's take another question now. Yes. So I'm coming. Let's just take some other questions. Sorry. Next question. What current in amperes will deposit 5.4 gram of aluminium in 2 hours? In 2 hours. Molar mass of aluminium is 27. 1 F is 96,500 coulomb per mole. Yeah, so this is very simple. You are dealing with what? You are dealing with mass. What's the formula for your mass? M is equal to mq over nf. Again, why don't we use the first formula? We don't have our z. It's as simple as that. So what's your mass? 5.4. What's your molar mass? 27. Then what's your q? I. That's what you're looking for. Current times what? What's your time? 2 hours. I told you to convert hours to seconds. Then 60. Then 60 over n for aluminium. We said it the other time. 3 times 96,500. So just cross multiply. 5.4 times 3 times 96,500 is equals to. Yes, let me press this one from my own end, but let me write it first so that. Yes, 5.4 times 3 times 96,500. That is what? Yes, so I have 156,3300 is equals to 27 times 2 times 60 times 60 will give me what? 27 times 2 times 60 times 60. Yes, so that's so that give me 194,400 I. So yes, I've just divided both sides by my I. So I'm going to have 194,400, 194,400. I is equals to. So yes, what do we come up with? So 156,3300 divided by 194,400. So that gives me 8.04 ampere. So yes, that's my answer to that question. Yes, I believe we got it now. Yes, let's take another question on that now. Yes, for subsequent questions, until I tell you to do otherwise, once I write the question, try to solve it yourself. Just pause the video and try to solve it yourself before you then watch the solution. That will make you to understand it better, and it will make it to stick deeper and help you to understand it deeper until the knowledge you have in it is well grounded and very intense. So yes, let's move on now. Okay. They said incoming. What is the quantity of electricity? What is the quantity? So you are looking for your Q. What's the quantity of electricity required to deposit 128 grams of copper from molten copper to chloride? So Cu is 64, F is 96,500 coulomb per mole. Yeah. So yes, just pause it, try it on your own. Let's see what you come up with. I'm sure you've done that now. Yes. So let's move on. So you have M is equals to MQ over NA. Why are we using this formula again? Why aren't we using this one? You use this formula when you are dealing with volume. But what is a gram? That's your mass. You use this formula when you are dealing with mole. But what's the mass? So yes, what's your mass? 128. What's your molar mass? 64. We are looking for Q, quantity of electricity, over what's N? Your N for copper is what? 2 plus 96,500. And it's very important to go over this topic and master your formulas again even after this video. So yes, let's multiply 128 times 2 times 96500 is equals to 64 cube. So I can even try to solve this without using my calculator. This will give me 2. 2 times 2 times 96500. That will give me 386000 columns. This is 3.86 times 10 raised to power 5 column. Yes, so this is my quantity of electricity. Let me give you another one. So you just try it and you see if you'll be able to get it. We are still having problems with the calculation so far. Just give it a playback and watch all the calculations for this video from the beginning again. You get to understand it better and your knowledge in it to be grounded. Yeah. So yes, we are trying this one. What is the mass? What is the mass of copper deposited at the cathode by the passage of 32,000 coulombs? That's what I said. Units, which one have the unit coulombs? That's your Q, the quantity of electricity. Through your C is 64. So let's solve this. Yes, you can pause it and try to solve it on your own. I'm sure you've done that now. Let's go. N is equals to MQ over NF. What's your mass? That's what you are looking for. What is the mass? What's your F? Molar mass 64. What's your Q? 32,000. So it's not great time that they will give you your Q to be what? IT. So you just know once they're giving you straight, you don't need to use IT. Then what's your N? Q times 96,500. So can you help? So let's just try to press. Then you'll see what we're going to come up with. So yes, for the upper part we have 2048000. For the lower part you have 193,000. So my mass will give me what? My mass is going to give me 10.6 grams. 10.6 grams. So yes, that's just for that. That's for that. Let me give you another one to try now. Oh yes, so let's take another question now. I will just write it. Then you try it first, then we solve it together. So they said copper 2 tetroxosulfate 6 is electrolyzed using copper platinum electrodes. How many grams of copper? How many grams of copper are deposited when a current of 0.386 ampere is passed for 50 minutes? Then they gave you the molar mass and your F to be what? 96,500 coulombs. So yes, I'm sure you are trying it out now. Yes, let me solve it now. So your mass is what? MQ over NF. What's your mass? That's what we are looking for. How many grams? What's your molar mass? 64. You all know that your Q is what? I times T. What's I? 0.386 times T. I told you that when it's a minute, it's 50 times what? 1060. You just multiply by 60 when it's a minute. Multiply 1060 when it's in what? Seconds. All over NF. What's N? 2. That's your power. Then what's F? 96,500. So you can just press in your calculator and let's see what the answer is going to be. Yes. So, okay. Yes, what do we get for the top? 64 times 0.386 times 50 times 60. Yes. I'm sorry, I'm trying to get the calculations. Yes, so if you have a calculator there, you can just press it. Yes, but my answer here is what 0.384 gram. So that's the final answer. Yes, that's the final answer I have here. So yes, let's take another question now. Let's take the next question now. So yes, I think we've perfected that of mass. So let me just give one more question. Then we go to volume, then mole. The only difference is that just follow the formula. When you are giving volume, you use this. When you are giving mass, you use this. When you are giving mole, you use this. Then after that, you take the special cases, and that will be all. Yes, one more question on mass. They said, okay, let's just take this one more question. They said the quantity of electricity. Okay, let me just give this. Please pardon me. I'm trying to look for a suitable question. I don't want to take the complex case yet. Okay, a current, sorry, not a quantity, a current of 20 ampere is passed for 30 minutes. During the electrolysis of gold 3 tetraoxosulfate, the mass of gold deposited is. They gave you the molar mass of gold to be 197. I'm sure you are very smart. You should be writing your parameters by now and almost done with your solvings. So yes, let's go. You've been giving your current, this is your time. Then the mass, M is equal to what? MQ over what? Over NF. M is equal to, what's your molar mass? 197. What's your Q? I times T. What's I? 20 times, what's time? 30 times 60. Over, what's N? I told you gold is what? 3. They will give you that in the formula. What's F? 96,500. So let's see what this gives us. 197 times 20 times 30 times 60. So you have what? 7092000 over, for the down part you have 289500. So yes, let me just try to divide 7092000 divided by 289500. So yes, my answer here is 24.497. So yes, that's just 24.5 grams. So that's my answer. I believe that's what you got when you tried it on your own. Yes, let's take another question together now. So we move to volume. So yes, it's just the same approach. And please let me beseech you, if you've not gotten it well up to this point, can just play back the video, then try to watch it over and over again until you have a full grasp of the topic. Yes, another question now. Yes, so we are going to volume. What volume of oxygen measured at STP would be lipated? I'm sure you must be writing your parameters and choosing the formula to use. By passing a current of 10 ampere through acidified water for 965 seconds. They gave you the molar volume of the gas to be 22.4 dm³. They gave you F to be 96,500 columns. So yes, can you just try that out? Just use your formula. Volume is equal to molar volume Q over NF. Yes, what's the volume? What's the molar volume? That's what 22.4. And what's your Q? Q is what? IT. Then they've given you the I, that's what 10 amperes. They've given you the time, that's what 965 seconds. It's in seconds already. Over N. What's the N for oxygen? Oxygen is always what? Oxygen is always 4. I told you that already. Oxygen is 4. So you have 4 times 96,500. Yes, let's try to press. Yes. To make an accurate guess, my answer will be 0.56. But let me just confirm from my calculator and see the answer that I'm going to get. Yes, so that's what 0.56 dm cube, because it's what? It's volume. So the unit of volume is dm cube. Then let's take another question now. It's not getting confusing. Yes, don't forget to hit the like and subscribe button, then drop wonderful comments, and you can comment another topic that you want us to make a video about. We'll definitely do that. Yes. Okay, let's take another question on mole now. How many moles of zinc would be deposited by passing 5 Faraday of electricity through a solution of zinc tetraoxosulfate 6? Yes, so this is it. They are asking for moles. What's the formula for your mole? Mole is equal to what? Q over NF. It's as simple as that. So mole is equal to, what's your Q? They said they passed 5 Faraday of electricity. Yes, so that's essentially your what? Your Q. 5 Faraday. Do you understand? So you put it 5 Faraday. Please take note of what I'm to explain here. So your Q is what? 5 Faraday coulombs. So it's actually 5 times 96,500. You have to write it in full, but it's the same thing over what zinc. That's what? 2F. So you can actually have written what's Q? 5 Faraday. 5 times 96,500, right? Over 2 times what's F? 96,500. So it's just the same thing. So this will cancel this, or this cancel this. So you are left with what? 5 over 2, 2.5 moles, or still 2.5 moles. So yes, the question seems a bit technical, but just know how to identify your parameters. 5 Faraday of electricity. This is the quantity of electricity. That's the Q. 5 Faraday coulombs. Yeah. So that's just that about that question. Let's take another question on mole now. Okay. I will give a question on mole now. Can you solve? Yes. 2 more questions, then we start the complex cases. Then once you are done with everything you need to know on this topic. Yeah. So what quantity of electricity will liberate 0.2 mole of oxygen molecules? I'm sure you are trying to solve it now during the electrolysis of water. So yes, let's solve this. They've given you the mole already, 0.2 mole. What's the formula? Mole is equal to Q over NF. Then what's your mole? 0.2. What's your Q? Q is what? That's what you are looking for. What quantity? Over what's N for oxygen? That's what? 4 times 96,500. Q is equal to 0.2 times 4 times 96,500. Q is equal to what? So yes, so your Q is what? 77,200 coulombs. 77,200 coulombs. Yes, one more question before we go to the complex cases. I will say you should try this on your own and see if you've really gotten the concept well. Yes. What is the quantity of chlorine in moles? What is the quantity of chlorine in moles? liberated when a current of 15 ampere is passed through molten potassium chloride in 1930 seconds. Let's solve it now. Yes, what's the quantity of chlorine in moles? So you are dealing with mole. Mole is equals to Q over NF. So what's the quantity of chlorine in moles? So you are looking for the quantity in moles. So you are looking for your mole. Yes, you know they are not saying what's the quantity of electricity of chlorine. So it's not Q. What's the quantity in moles? So you are looking for your mole. Then what's Q? IT, right? What's your I? 15. What's your T? 1930 seconds. Over NF. What's your N? For chlorine gas, that's what 2 times 96500. Yes. Mole is equals to. If I solve it very well, yeah, I can see 1.5. But let me cross check from my own calculator and see what the final answer will be. This is just the test, so it may not really be accurate. Oh, let me just confirm. Let me just do it straight. 15 times 1930. Yes, let me just confirm. This damn part should be 193000. Then 15 times 1930 is what? Is 28950. So yes, when I divide it now, I got 0.15 more. So I'm somehow close, but that's not accurate. Yes. So this is all about that. So let's go for the special cases now. Yes, for the special cases, they will give you two elements. They will give you two different elements. What you have to do is to compare the elements together. What you have to do is what? To compare the elements together. Just compare the elements together. Yes. And if I want to give you to make it easy, you know that F is common to everything, right? F is common to everything. So just make F the subject for both and say that your F is equal to what? Your F. You know, F is the same thing as F. 96,500 is the same thing as 96,500. Yes. So you just make F your subject of the formula. Make F the what? The subject. This will guide you through. Make F the subject. So let's begin to take those special cases now. It starts from the first one. Yes. So I have a question here. They said a quantity of electricity liberates 1.5 gram of aluminium from its ions. The mass of silver that will be liberated by the same quantity of electricity is. So yes, let's solve it now. He said 1.5 gram of aluminium, the mass of aluminium is 1.5 gram. Then silver, they said what is the mass of silver? Mass. Then they said the quantity of electricity is the same. The Q for this one is the same as the Q for this one. So since you are dealing with mass in both cases, just make F the subject here. So you have something like mass is equals to mq over what? Nf. But I'm saying make F my subject here. I will have what? Mnf, right? Is equals to mq. Divide both side by mn. So F is equals to what? Mq over mn. So I can say molar mass Q over Mn for what? For aluminium is equals to, this is also what? Mass. So we follow the same approach. molar mass Q over Mn for what? For silver. What's the molar mass for aluminium? That's what? 27. You should be giving Al is 27, Ag is 108. 27 times Q, right? Over what's your M? The mass 1.5. What's your N for aluminium? That's what? 3. That's 3. We are confused about how I got this formula. I said you make F your subject. That's what I read here. Make F your subject. So cross multiply. MNF is equal to capital letter MQ. Divide both sides by Mn. F is equal to what? MQ over Mn. So MQ over Mn. That's your what? F. That's your F. Yes. So let's go. What's the molar mass of Ag? 108. Right? What's the Q? This Q. What's the Q for? Let's just write it. Over what's the mass for silver? We don't know it. That's what we are looking for. What's the N for silver? 1. They said the same quantity of electricity. So your Q of this one is the same as your Q of this one. So they cancel out. So you have 27 over 1.5 times 3, that's what? 4.5 is equals to 108 over M times 1, that's what? M. So you cross multiply from here. 27M is equals to 108 times what? 4.5. So you divide both sides by 27. So this is what? (108) times 4.5. Then my answer divided by 27. Let me just try to see. Yes, 108 times 4.5 divided by 27. So that's 180. Yes, let me just try to show it here. You have 4860 over 27. So if you divide it, your mass will what? Yeah, 18.0 gram. 18.0 gram. Yeah. So this is my answer. 18.0 gram. 18.0 gram. So just follow the procedure. The first thing you do is to get your what? Your F. Make F the subject. Make F the subject. Let's take another one now. But you can actually play it back also. You can play it back. Yes, another question now. Okay, yes. If 24,000 coulomb of electricity are required to discharge 0.25 mole of potassium from a molten potassium chloride. Yes, then the number of coulombs required to discharge 3 moles of lead from lead to bromide is. So yes, let's take this question together now. Now you have the first one, potassium. 24,000 coulomb of electricity. That's what? That's your Q. Coulombs. The unit is coulomb. 24,000 coulombs. Then the number of coulombs required. That's for the next one, bromine. Or is it lead? Lead to bromide. The number of coulombs required, we are looking for your Q. To discharge, okay, this one is 0.25 moles for potassium. Mole is what? 0.25 mole. Then this is what? 3 mole. 3 mole. So yes, let's solve. You are dealing with mole, so you write out your formula for mole. Mole is equals to Q over NF. And then you make something your subject, that's what? Your F. So you have mole NF is equals to Q. F is equals to Q over mole N. F is equals to Q over mole N. So just put this one into the formula. So you have Q over mole N, right, of potassium is equals to Q over mole N of what? Of lead. So yes, let's try to solve. What's the Q? Q is what? 24,000. What's the mole of potassium? 0.25. What's N? N for potassium is what? 1. What's Q for lead? That's what you are looking for. What's the mole? Mole is 3. What's the N? N is what? N for lead is 2. So yes, let's try to solve. Q is equals to 24,000 times 3 times 2 over 0.25. Q is equals to, yes, 576,000 coulombs. So that's that. So give you one to try now. I'll give you one to try so that you just know how to write the formula to use, because that's the most important thing. How to derive your formula. So this next one, you will be the one to try it out. Just pause the video, then make sure you are able to do it before you move on. Yes, let's go now. Another question. If 6.4 gram of copper is deposited in a copper coulometer connected in series with an Hoffman voltmeter, the volume of oxygen liberated at STP is. So this is actually another case. Yes, but it's just the same approach. Just check it out. Copper and what? And oxygen. They gave you the mass of copper to be what? 6.4 grams. But in the case of oxygen, they gave you what? Volume. And they ask you to find it. So what are you going to do? For mass, write it out. MQ, mass is equals to MQ over what? NF. Make F your subject. MNF is equals to what? MQ. So your F is equals to MQ over what? MN. For volume, write out your formula. MVQ over NF. Make F your subject. VNF is equals to MVQ. Divide both sides by VN. F is equals to MVQ over VN. And you know that your F is the same thing as your F. So you say MQ over MN of copper is the same thing as your what? MVQ over VN of oxygen. So what's the molar mass of copper? 64. What's the quantity of electricity of copper? We aren't given. Then what's the mass of copper? 6.4. What's the N of copper? 2. What's the molar volume of oxygen? 22.4. What's the Q? They said they are connected in series, so the quantity of electricity is the same. Once they don't give you, you know that it's the same. Then you have the volume of oxygen. What's the volume of oxygen? That's what you are looking for. Times, what's the number of mole? 4. So from here you should be done. Just cross multiply. You have 64 times V times 4 is equals to 6.4 times 2 times 22.4. So from here you can divide and get your answer. Yes, so your V will be what? V will be equals to 1.12 dmq. 1.12. Oh, maybe I should confirm before, but I guess that's correct. Yeah, so that's 1.12 dmq. 1.12 dmq. Yes, another question now. I'm sure you are getting it now. I'm just taking more questions to ensure that you do what you get it well. So please, this last question, make sure you analyze it on your own. Before you watch this last one on complex cases, I still take 3 special questions though. But before you watch this next question and you've not gotten it, make sure you go back to the previous videos, to the previous questions we've solved on special cases. Then try to solve them again on your own until you understand. Please, if you don't do that, don't watch this next one. Yes. Let's move on now. .1 Faraday of electricity. I'm sure you are trying this out already. Deposited 3.2 gram of copper in the electrolysis of an aqueous solution. Then the number of moles of copper that will be deposited by 0.6 Faraday of electricity is. Let's move. Now they gave you 0.1 Faraday of electricity. If I'm to ask you what's that, that's the what? That's the Q, quantity of electricity. Remember that question we took the other time, we say like something like 3 Faraday of electricity, yes, something like that. So let's go. We are giving copper. Then I think the other one is also copper. Copper in both cases. So this is copper 1, this is copper 2. So for your first copper, you have what? The quantity of electricity to be what? 0.1 Faraday. You deposited what? 3.2 gram. Mass is what? 3.2 gram. The second copper is what? 0.6 Faraday. They said what will be your what? Your number of moles. Your number of what? Moles. So there's actually a difference. So yes, for your mass, you have what? MQ over NF. MNF is equals to MQ. F is equals to MQ over MN. The same thing for your mole. Mole is equals to Q over NF. Mole NF is equals to Q. F is equals to Q over mole N. You get it now? So you can say MQ over MN of copper 1 is the same thing as what? Q over mole N of copper 2. Sorry for the marker. Okay, yes. What's the molar mass of copper? 64, right? What's the Q for copper? 0.1. What's the M of, okay, what's the mass of copper? 3.2 gram. Then what's the number of Faraday of, what's the number? That's 2. What's Q for this second copper? 0.6 Faraday. What's the mole? That's what you are looking for. What's the N? Your N is your what? Is still 2. So let's try to solve. So we have 64 times 0.1 times mole times 2 is equals to 0.6 times 3.2 times 2. So we have what? We are looking for mole. So we have something like this. Mole is equals to 0.6 times 3.2 times 2 all over 6.4 times 4.1 times 2. So yes, let's see what this will get us. Yes, I'm trying to solve it off now. 3.2 times 2 was 6.4. So it will cancel this one. 2 in 0.6, that was 0.3. 0.3 over 0.1 will give what? 3 moles. So that's the answer. 3 moles is correct. 3 moles is correct. Yes. So we are done with that. We are done with calculations in electrolysis. There are actually 3 special questions. But let me just see if I can be able to just Yes, from the first law of electrolysis, I said that the mass is directly proportional to your what the quantity of electricity. So M is equals to Z cube. In case you can be asked, this is the graph. Your mass is on the vertical axis, your Q is on the horizontal axis. So it's a direct relationship. So this is it. This is it. Yes, and there are some questions where they will ask you that how many kilograms instead of how many grams. Yes. So once you get to answer in kilogram, once you get to answer in gram, to convert it to kilogram, it will be what? Divided by 1000. So that will be all for this question. If you have any question you can be able to solve, you can join our online tutorial. This is the celebrated Achievers Mentorship Program. Champ, we are bringing academic dreams to reality. Thanks for staying through with us. Don't forget to like, share, subscribe, and give comments.